Hi class, how are you all? Today we're going to be learning about hyperbolas. We're going to learn about all of their properties, their features, and then how to graph them. All right, so I have here the definition of a hyperbola that your book gives. I'm going to actually put some other links so you guys can look at some different 3D graphics of where hyperbolas actually come from. So they're actually, if you take this double cone here, like all of our conic sections come from, if we slice it, if we get these two kind of parabolic shapes, they are called hyperbolas here. So the definition is a set of all points in a plane, the difference of whose distance is from two fixed points called the foci, don't say foci, foci, is a positive constant. First thing, I have a table here for you that we're going to fill out. I know a lot of us in our class are very formulaic, so I'm going to give you guys some formulas that you can use to actually write and define all of the different features of our hyperbolas. And then I've got a couple hyperbolas here. We're going to color code them. So if you have different colored pencils or something, or all of your beautiful gel pens, I'm talking to you, Emily, you can use those to fill this table out. We're going to then go through and actually look at a graph. You know me, I'm very visual. So for me, I don't really use this chart, but I thought it would be helpful for a lot of you guys. All right, so first things first, we have two different orientations of hyperbolas. So hyperbolas, when we're thinking of their orientation, all right, they can either be horizontal or vertical. So a horizontal hyperbola looks like X-ish. It looks like this. The branches open to the right or to the left. I call it X-ish. All right, or they can be vertical. A vertical hyperbola, it looks, the branches open up and down. And to me, this looks Y-ish. Now it is helpful to think about these in terms of X-ish and Y-ish because that's going to help you guys remember the different equations. So the standard equation of a horizontal hyperbola is x minus h squared over a squared minus y minus k squared over b squared equals 1. All right, and the reason I'd say this is helpful that it's x-ish, you guys are going to be able to use that to remember that the x value comes first. So in my equation here, it looks very similar to our ellipse equation, however, we have a subtraction sign in the middle. Now the first, we're having our x first, so in our x-ish shaped hyperbola. All right, then we have a vertical hyperbola that is y-ish. So if in the x-ish, x came first, what do you think comes first in the y-ish? Y. So y minus k squared over a squared minus x, whoops, I didn't write x, I wrote h. Bloop, I love my Apple Pencil. X minus h squared over b squared all equals 1. Okay, so like I said, in this vertical, y comes first. All right, so we've got some different variables here. We've got x and y, which we all know. We have h and k. So remember, h and k, I should add this on here, represent our center. So let's add it here. So center, I should have put this in my chart, is hk, right? Our center is always hk. Then we have a squared. So a is the distance from the center to the vertex. The vertex is actually a point that lies right on our branch. Then we have b. B is the distance from the center to the co-vertex. However, in our hyperbola, this co-vertex is kind of a phantom point. It's not an actual point on the hyperbola. It's just like a guiding point for me. And then C, that's of course our distance from our center to our focus. So just like we had when we talked about ellipses, our hyperbolas also have these points called foci. One is a focus, two are foci. And then we have, in order to find this point, we need that special equation that we used. So we talked about this equation before, but the equation's a little different with hyperbolas than ellipses. So with hyperbolas, in our standard equation, we have a subtraction sign there in the middle. So in our equation that we're going to use to help relate our a, b, and c values, we have a squared plus b squared equals c squared. So once again, I always have my little trick to memorize something. If the equation has subtraction, the kind of foci equation has a plus sign. So same thing with our ellipses. Since our standard equation of an ellipse has a plus sign, that equation for a, b, and c has the subtraction sign. All right, so let's move on. So then we have vertices. So vertices, these are points that are actually right on the branch. So they are kind of our like bottoming out point, or are the 2 points that are closest to the center. That's how I'm going to define them. So the points that are on the actual branches closest to the center. So for if we were going to write out their equation for them, or I guess it's not an equation, just some variables that you can use to write the names of the coordinate points. So with our vertices, we could write them as being h plus a, k, or h minus a, k. Okay, so if we think about that, so if I'm down here, I'm gonna look down here at my actual graph. So I'm gonna first plot my center. So what do we say? We'll do center is black. So center, I'll mark it there with a C. And we're thinking about the vertices. So the vertices are over here. Remember I said they're the points along the branches that are closest to the center. So remember these values, these swoops, these are the branches. All right, so the points closest to those are the vertices. I'll label them with a V. So for thinking about them, if this point's here in the middle C is, if C here is H and K, if I add A, I'm gonna be over here at the vertex, right? So if I add A, I'm gonna be here at this point, which is H plus A, okay? And then similarly, if I'm here at the center and I subtract A from my X, I'm gonna be over here and I'm still at the same Y variable or the same K. So that's where those values come from. Okay, so let's do the same thing over here with our vertical. So once again, we've got our center. Oops, wrong color. Our center is here, and then our vertices are here. So see, these are the 2 points closest to the center along the branches. So for this example here, or for our vertical, the actual X value of this vertices does not change from the X value of the center. So if we were going to think about this in terms of kind of a formula or an equation to use, we would say this is H and then K plus A and H, K minus A. Okay, so the other thing I want to add to this chart here, so the vertices, these are actually also the endpoints of our conjugate, transverse, transverse axis. Okay, and the length of the transverse axis is 2a. So looking down here on our graphs, so if I were to label this here, so this actually line segment here is called the transverse axis. Okay, and remember the distance from the center to the vertex is A. So if this is A and this is A, the entire length is 2A. Okay, all right. So same thing happens with our, oh geez, with our vertical. So with our vertical here, its transverse axis, excuse me, runs vertically. And once again, its length is 2a. All right, then our covertices. So like I told you guys before, covertices are not actual points on the hyperbola. But however, they are helpful because they're going to be helpful when we are creating and graphing our hyperbola. So our covertices, remember, they're not actually points, not on the hyperbola. They're just guidelines. All right, and then its axis. So the covertices are going to be here. And there's also an axis here. So we call this axis the conjugate axis. Okay. So I remember conjugate starts with a C, covertice starts with a C. And the conjugate axis has a length of 2b. All right, so if we're thinking about the points here, we could name them as hk plus b, hk minus b, and for our vertical, it would be h plus b, k, and h minus b, k. Okay, so like I said, these are just some formulas to help those of you who like something like this. All right, then we have the foci. So the foci, they, once again, they're going to, the foci are going to be points within the branches. So I think, oh, these are my little baby foci. The branches have to hold them. They have to be within the branches. So if for some reason you calculate and you think your foci are outside of these branches, you probably made some sort of a calculation error. All right, so our foci, let's do them red. So in our picture here, we've got our foci. There are these 2 points here in a vertical. My foci are going to be here. Like I said, they are inside of the branches. They are not outside of them. They are inside of those swoops. And they're always going to be right along the same value as your vertices. Right? So they'll be straight out from the center. You'll always have center, vertice, focus, or foci. All right, guys. So our equation that we can use, if we like our equations, we could have h plus ck, h minus ck, and h k plus c, h k minus c. Okay. All right, then we've got a couple other points here. So we have, actually we don't have points, but we have some big asymptotes. All right, so our asymptotes are here. They run through the center. And to me, these serve as guidelines to where our branches go. Remember, our branches, they're not actually going to cross these asymptotes. I'll call them A, and A. All right. And our asymptotes, they actually have a formula that we can use. It's really nice. If you all remember, this is point slope form. And actually, this is the formula I do find extremely, extremely helpful. So our asymptotes for a horizontal are y minus k equals. So there are always 2 asymptotes. One will have a positive slope, one will have a negative slope. So I'm going to write these, although this represents 2 formulas. So we've got plus or minus, and then it's b over a. So it makes sense. So b in this case represents the change in y. A represents the change in x. So it's essentially our rise over our run, our b over our a. Oh, I didn't even color my conjugate axis now that I'm just thinking about that on this one. So b over a times x minus h. Okay. So really the formula for asymptotes is pretty easy, as long as you remember it is point slope form. So remember that point is going to be our center because our asymptotes always run through the center. And then the slope just comes from your a and your b value. So it's always going to be y over x. Remember, b can be y or b can be x dependent upon if it's horizontal or vertical. So y minus k equals plus or minus. So in a vertical asymptote, remember our a value represents that that vertical change. So that's the y change. So it's a over b times x minus h. Okay. All right. So like I said, these formulas might be helpful for you. They might not. Anyways, the color coding is cute. All right, so let's go on. So we've got a hyperbola here. We are given the graph, and we need to identify all of its features. All right, so the first thing, we need to figure out its orientation. So to me, I think, is it x-ish or is it y-ish? Well, obviously it looks more like an X. The branches go swoop out from side to side. So this is a horizontal orientation. It is X-ish, right? Okay. All right, now it's vertices. So remember the vertices, those are the points on the branches closest to the center. So first of all, where is my center? I don't know. Let me see. Actually, I do know. So if I remember, our center is always going to be equidistant from the foci and from the vertices. So if I am here at my, this is a focus right here. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. So there are 10 units in between our two foci. So if I split that in half, I'm right there. So there's my center. I'm going to label it with a C. I'm going to fill in my center part because that's what I figured out first. So my center here is at the point -1, -1. All right, so remember the center is equidistant from the vertices and from the foci. All right, next, our vertices. So I can see my vertices. Remember, these are also equidistant from the center, and those are going to be our points closest to the center on our branches. So here, there would be one of my vertices. Here's my other vertex. All right, so those points are located at -1, 2, 3, 4, 5, -5, -1, and 3, -1. Okay. All right. Let me clean this up for us a little bit. All right. So you could have used your formula there, but for me, I am quite visual. I actually prefer to just draw this part and then label them based upon what I've drawn. All right, so our transverse axis there, remember guys, that is the axis that travels right here from vertex to vertex. Let's do a different color. All right, I'm gonna call that my TVA. I used to have a water polo coach called TVA. Okay, so our transverse axis, remember that is 2A. So our A value here, for me, I just count. A is 1, 2, 3, 4. A is 4. There are 4 units between my center and my vertex. That is what my A is. So my transverse axis is 2A. So if I wanted the length of the transverse axis, I could say 2 times 4. So that length is 8. So my transverse axis, though, it's just this. It's actually just a line segment there. Okay, so from there we know A equals 4. All right, now we have our foci. So it's really nice. Our foci are actually given to us in this drawing. or in the sketch of this graph. So our foci are here at 1, 2, 3, 4, -6, -1. And the other focus is here at 4, -1. Okay, so remember, there is that variable c, which is the distance from the center to the focus. So from here to here, c, lowercase c, don't be confused with center c, they're variable c. So it is 5, right? We know c is 5 because it's the distance from the center to the foci. I guess I'll color them red here. Okay, now we need to think about our conjugate axis. All right, how do I know my conjugate axis? I could maybe take a guess at where it is, but I'm not exactly sure. So in this case, I am going to use my equation of the foci because I could take a guess at where it is, but I want to be exact. I want to be precise. So in order for it to be precise, I know the conjugate axis. We're going to have our b value is what we get from our conjugate axis. So I know 2b is the length of the conjugate axis. I also know that it's perpendicular to the transverse axis. So I know it's going to be coming through the center. I know it's going to be coming up here, but I'm not exactly sure how long it is. So I need to figure out b. So that's where we're going to use our a squared plus b squared equals c squared. All right, so we know a is 4, so a squared is 4 squared. We don't know b, so I'm going to leave b squared as a variable. And then I know c squared, so c is 5, so 5 squared. All right, so we've got 16 plus b squared equals 25. B squared is 9, so b is 3, plus or minus 3, right? All right, so if b is 3, 2b must be 6, b is 3. So my conjugate axis is going to be 6 units long, 3 units up and down from my center. So 1, 2, 3. I could call this my covertex. It's not a real vertex because it's not an actual point. It's just a guideline. And then 1, 2, 3. There it is. I'm going to mark those with dashes because they're not actual points, but I still will call them my covertex. And then I've got my conjugate axis here. All right, 6 units long. All right, so now I need to figure out my asymptotes. But where are my asymptotes? Well, I'll tell you this. So my asymptotes, they always run through the center. We know our equation that we could use to write the equation of our asymptotes. And a nice, easy way that we can actually draw them out is we can connect. So we can make a little box here. Yeah, I'll make it black. That runs through my vertices and my pseudo covertices. And then I know my asymptotes actually run through the corners of this box in the center. So I make my X box. We'll talk about this more on the next page. So, oh no, I don't want pink. Okay, beautiful. Asymptotes drawn. Call those capital A. All right, so we do need to write their equation though. All right, so remember guys, our equation for our asymptotes, we can use that point slope form. For these specific asymptotes, it's not exactly clear where they cross the y-axis. I can't see their intercept. So I'm going to use my equation. So remember our equation is so we've got our horizontal. So our equation, y minus k equals plus or minus. So our b over a times x minus h. All right, so h and k, remember that comes from our center. So our center is at -1, -1. So y plus 1 equals plus or minus. So now I need b over a. So b is 3, a is 4, times x plus 1. Why am I scrolling? And there we have it. And we could distribute, you could move them around, but honestly, I am perfectly fine if you leave this in point slope form. It's beautiful. I love it because I can easily see where your center is. And I can easily see your B and your A. It's fine. All right. Sometimes it's easy to spot, write your equation and slope intercept because you can easily see the y-intercept, but for this case, we can't. All right, so now we need to pull this all together and we actually need to write its equation. So the equation of this, remember, we've got a horizontal. So our equation is going to be x minus h squared over a squared minus y minus k squared over b squared equals 1. All right, so now we just plug our points in, plug our values in. So I know h and k, that comes from my center over here. Remember this is, whoopsie, h, k. All right, so we've got x minus 1, so x plus 1 squared, all over a squared. So a is 4, 4 squared is 16, minus, now we have y minus k, so y plus 1 squared, all over b squared. So b in this case is 3, 3 squared is 9. So we have our equation, not bad. All right, so now moving on. So now we may be given an equation and we need to graph it. So we just had a graph and we wrote the equation. Now we're gonna do it in the other order. All right, so the first thing I do, it says we need to find the center, the vertices, the foci, the equation of the asymptotes, and then graph them. So I always start by actually graphing them. So the first thing I graph is my center. So I look at my equation, I see I have x squared. There's no plus or minus there with that. Just making sure I squared something before. So my center here is going to be, I've got the x value first. I know it's orientation also. First orientation. It's horizontal. We've got x first. It's x-ish. So I am going to add that to my list. I'm going to say it's horizontal. All right. So the center is at the point 0, +1. Remember, within our equation, we always have subtraction signs, so you actually flip the signs here. So I start by plotting my center at 0, 1. All right, next thing I do, I look at my equation. In my denominators there, I've got 16 and 4. So remember, 16, I'm going to take the square root of this number. So I have a squared equals 16, so a must equal 4. Our second value, this 4 here, this goes along with my b value. So if a is 4, b is going to be the square root of 4, so b is 2. All right, so what I'm going to do next is I need to plot these values. I'm going to plot essentially my transverse and my conjugate axes. So a goes in the x direction. A is beneath x, so in the x direction, I'm going to go right and left from the center 4 units. So 1, 2, 3, 4, 1, 2, 3, 4, and I'm going to mark it. I'm actually going to mark it with a point because these are my vertices. Remember, whatever's first, so in this case, if the x is first, those are my vertices. There's my center here. All right. Now my b, I'm going to go up and down 2. So 1, 2. I'm going to mark that with a dash because that's my co-vertices, down 2. Mark it with a dash because they're not actually points on our hyperbola. So why would we need to mark it with a point? We don't. All right, I am going to now make a box using these values. It's just a guiding box. It helps us when we're graphing these. Super helpful. All right, so from here, I can write my names of my coordinate points of my vertices. -4, 1, and +4, 1. All right, and you can see we've added a to our h value here, and we've subtracted a from our h value, like we did in our chart in the beginning. All right, and then we need to find the foci. All right, also, I need to make my asymptotes. So after I've made my box, make your X box, right? You guys play Xbox. So I am going to make my asymptotes. So our asymptotes, they run through our center and through those corners of our X box here. Our guiding box. Okay. All right, so we have our asymptotes, we have our vertices, we have our center. I think I'm ready to graph my branches. I know my orientation is horizontal, so I know my branches are going to go left to right. So I'm going to swoop them out here and here. I'll make them black. And just do the best you can. I'm not worried about them running through precise points. While the left side looks much better. Okay, that's okay. All right, so now we need to find our foci. So we know where our vertices are. We know where our center is. We know A, we know B. So we can use our formula A squared plus B squared equals C squared to find our C value. Remember, C is going to tell us the distance from the center to our foci. So A 4 squared plus B is 2 squared equals C squared. So we have 16 plus 4 is C squared. So 20 is C squared. All right. So we'll take the square root of both sides. So C is the square root of 20. Now I can simplify that. So C is, I know 4 times 5 is 20. Square root of 4 is 2. 2 root 5. 5 is prime. We can't take the square root. All right. Now you could then go into your calculator, because I don't know exactly what 2 root 5 is, but I know 2 times, so the square root of 5, square root of 4 is 2, so 2 times 2 would be 4, so it's going to be a little bigger than 4, or I could use my calculator and find that exact value, which I did, and that is about 4.47. All right, so that C value was about 4.47. So up here on my graph, from my center, I can go in the positive direction about 4.47. So that'd be about here. I guess I'll do a different color. Do it in red. My focus. And then it's over on this side too. I've got my 2 foci. All right, but we do actually need their coordinate point. So in this case, it's nice because our center starts with an h value of 0. So our 2 points here would just be 2 root 5, 1 and -2 root 5, 1. Okay, so those are the equation of our foci. I mean, the coordinate points of our foci. All right, now we need the equation of our asymptotes. So for this example, it's actually quite easy. I can clearly find my y-intercept here. So I don't really need to use my, I could just look at the graph and find the y-intercept, which is just at +1. And then I see my, my slope here. So here's my y-intercept. My slope, it looks like it rises 1 and it runs 2. So my slope is 1/2, +1/2, and then going in the other direction, it'd be -1/2 for the other asymptote. But I'm going to stick with be consistent. So we could say y is plus or minus 1/2 x plus 1 by looking at the graph. Or you can use our formula. So I know it's always going to be y minus k, but in this case, that comes from our center, our 1. So y minus 1 equals plus or minus. So in this case, it'll be 4 over 16 times x. All right, and like I said, I don't mind if you leave it in this point slope form. I'm going to simplify my slope. 4/16 is 1/4 x. Oh, so this should be 4. Okay, there we go. See, I made a mistake when I looked at my graph, but I didn't make a mistake when I had my equation. All right, okay, let's do it one more time. So we're done there. So we've got another hyperbola here to graph. So I've got y first. If y is first, I know it's going to be y-ish. My branches swoop up and down. So therefore its orientation is vertical. All right, next thing I do, I look at my equation and I look for my center. So my center, I can see it clear as day, h and k in my graph. So remember, this is k, this is h. So my center is at -2, +1. All right, so I'm going to graph it here, -2, 1. There's my center. All right, then I need to find my A and my B. So remember, A always associated with our first part of the equation. So A is going to go along with Y. It's going to go in the vertical direction. So A is 2. I took the square root of 4 to get that. B is 3 by taking the square root of 9. So I'm going to 1, 2, move up and down 2 units. So remember, whatever's first, those are your vertices. So plot those points, label them with a V. I like to label them with the letter because then I don't forget what those points represent. All right, then my B, it's going in the horizontal direction, 3 units, 1, 2, 3 in both directions. And this one I do with a dash. Those are my pseudo covertices. Then I make my box, just a guiding box. All right, from there, I'm gonna make my X box. Those are my asymptotes. All right, now I know my orientation, so I can swoop my branches out. And there you have it. Not as colorful and beautiful as the first one, but that's okay. All right. So now I need to name all of my points. So my vertices, I can just look at my graph and see them. It's at -2, +3, and -2, -1. All right, now my foci. I don't see them on my graph, so I need to use my formula. Remember, a squared plus b squared equals c squared. So we know a squared is 4, b squared is 9. And we're finding c squared. There's a scrolling. So 13 is c squared. So c, we take the square root of both sides, is root 13. 13's prime. I don't know the square root. However, I know the square root of 9 is 3. The square root of 16 is 4. So this is going to be somewhere between 3 and 4. Or you can use your calculator and find out that exact value, and it is about 3.61, 3.6055, something. Okay, so in this case, we need to, our foci, remember foci always lie within our branches, so they're going to be up here above our vertices, or below our vertex, above this vertex, below this vertex down here. And they are going to be that root 13 distance away from the center, going up and down. So, whoopsie. So I can plot them up here. So from the center, remember we said it's about 3.5 units from the center. So 1, 2, 3 and a little bit, it's going to be here. 1, 2, 3, and a little bit. It's about there. I'm going to label them with an F. And I need to actually find that exact value. So -2, 1 plus root 13 is the first. And -2, 1 minus root 13. Need more room for the foci. Sorry about that. All right, now we need the equation of our asymptotes. So remember, guys, we're going to use our point slope. Don't forget point slope. So the point, remember, that's our center, HK. The slope, it's going to be rise over run. So it's always the y over the x. So it's going to be, in this case, so it's, so y is our a here, so it's going to be a over b. So our formula would be y equals, oops, excuse me, y minus 1 equals plus or minus. So a is 2 over b is 3 times x plus 2. All right, and you don't have to distribute. That's fine. I'm fine. This is perfect. All right, it's nice too. I like using the equation like this because actually these parts of the equation come directly from our given equation, right? It's the same. All right. Okay, that's it for you guys today. Good luck. Try graphing. You've got 4 graphs to do.